So the last part that we're going to learn about today is finding out if a function has an inverse that is also a function. So we're going to work on determining if that's going to be a function or not. So here's a couple of points you're going to need to remember in order to do that. So the inverse function is a function if there is only one output y value for an input x value. So we can also use the vertical line test. If you draw a vertical line through a graph, then if the graph represents a function, the vertical line can only pass through a graph once at any given point. So you may have been exposed to this in algebra. So vertical line test just test, hey, is there more than one y value for each x? So each x should only go to one value of y. So an extra hint, polynomials with even degree. So remember degree, that's like the highest exponent. So that would be something like x to the 4 plus, some stuff. Have an inverse, but the inverses are not functions. They can be functions if you restrict the domain, but the point is to identify polynomials that have even degree are not going to be functions, because when you reflect that on the graph over the diagonal line y equals x, that function's going to turn back on itself, and it's not going to pass that vertical line test. So here's a couple ways that you can check visually in your calculator. So this is just one method that I'm just letting you know exists. You can clear out any graphs that you have in y equals, because if you have a graph in there, it's going to graph that too. And then what you can do is go to second and then the program button, and you want to select draw, which is on the left side of that menu. So your menu will look like this screenshot. And then you want to select number 8, which is draw inv, which stands for draw inverse. Okay. And then it's going to let you input some kind of function in there. You have to put parentheses around it, or else it's not really going to fully know what you're talking about, and it's going to leave out some information. So make sure that you put like the right hand side of that expression or equation in those parentheses, and then you hit enter, and it actually graphs the inverse function. So whatever function you put in, it graphs the inverse. So these screenshots are an example of a parabola. Right there, 2x squared minus 8. And the graph is not of the parabola, obviously, because the graph of the parabola would look something like that, only actually a little bit further down. But it graphs the inverse, and you can check the vertical line test there. So just a note, that exponent on the x is a 2, that's even, so its inverse is not a function. It's a relation, but it's not a function. So if you're doing it that way, and you want to try graphing something else, or you're moving on to other problems, it is a good idea to clear the drawing, because it will keep on representing that inverse drawing in there after you go and do other things. So you can do that, and that's number 1 in that menu. Another way to test if a function has an inverse that is also a function is called the horizontal line test. So if a function f has an inverse that is a function, the inverse function, if there is no horizontal line that intersects the graph of the function f at more than one point. So in this case, you're going to look at the function, and you're going to do the horizontal line test on it. So you're going to draw a horizontal line, and if that horizontal line touches the graph more than one time, then it's a relation and it is not a function. So for example, a parabola would not pass the horizontal line test because if I draw a horizontal line, it could touch the graph more than one time. So the inverse of that is not a function. Okay, even though a parabola is a function, but the inverse of the parabola is not a function, because here's basically what that inverse would look like. It would look like that if we graphed it. So that's one way that you can also tell if something is going to be a function or not. So let's look at applying that knowledge to a couple of problems. So they're asking me, is the inverse a function? And they give me a function, and one thing that I could do is look at the exponent, and that's odd, and generally odd degrees have inverses that are functions. So I can say just from that, yes, it's f of, with a little -1 is the f inverse is a function. So I can tell just from that information. Another way to do it is in your calculator, which I cannot bring up in this program, but I can show you when we get back into class. So that would be using the calculator in order to graph the inverse or draw inverse. Now, another way that you could do this problem is to think about the graph of f of x. Now that's a cubic, and I see that we have a -2 on the end. These actually shift the same way all other graphs shift. So cubics kind of look like a squiggle, like that. And they are on a coordinate plane. Now this cubic that we have here is shifted down 2 from the origin, and I know that because of that -2. So if that were my coordinate plane, that middle of the squiggle right there would be at -2. So that's basically what my graph would look like if I just sketched it. And then I can think about doing the horizontal line test. Horizontal line, it only touches once, and no matter where I draw it on that graph, my horizontal line's only going to touch the graph one time. So one touch on the graph means that it is a function. So this is the horizontal line test. Okay, so really we have 3 different ways to decide this. Let's try another one. So pause the video and try to decide with one of those methods, either looking at the screenshots where you do draw inverse with the vertical line test, or you can do the horizontal line test on the actual function. So try that, and then I will actually tell you the solution. So a couple things here. I see that we have degree that is 2, which is even, which means the inverse is not a function. Okay, the other way that you could tell by looking at this is to graph it. So if I just sketch a coordinate plane here, I know that we have a vertex that is going to be at 1, -3, because this is in vertex form. So 1, 2, 3, there's my vertex. And I know my parabola opens up, so I'm just doing a quick sketch of this shape. And then I could do the horizontal line test. Okay, so if I do a horizontal line and it could touch my graph more than one time, that means it is not a function because of that horizontal line test. So let's take a second and think about what is what does horizontal line test actually mean? So let's think about inverses for a second. So I mean, I'm totally done with this problem, but I just want to take it a little bit further for us. So if I'm checking to see if something's a function, I want to do the vertical line test on that possible function. What does that have to do with inverses, and why would the horizontal line test work on that? So if I think about that, and I think about what do we know about inverses, well, I know that the x and y's are switched, and it looks like a reflection across the line y equals x. So I just sketched in the line y equals x, and if I think about what that vertical line would look like if I reflected it, it would look like this, which is a horizontal line. So that's why you can either do the vertical line test on the thing that you're trying to test, or you could do the horizontal line test on the function if we're trying to decide if the inverse is also a function. So the next two problems are you-dos. I want you to work with your shoulder partner, maybe if nobody's sitting there, somebody nearby. And partner A is going to start by asking partner B the guiding questions, and partner B is going to solve, okay? And then you're going to switch roles on the next problem. This is meant to help you talk through the problem, because generally talking about problems helps you remember how to do them. There's the you-do